Welcome everyone to today's seminar on the SPHN data ecosystem for fair data. This ecosystem is actually based on the semantic web technology. And today I would like to give you an idea what kind of components are needed to actually make such an ecosystem a success. And this is also why I have this question below, why you need more than only an ontology. My name is Sabine Österle. I'm the team lead for data interoperability at the Personalized Health Informatics Group at the Swiss Institute of Bioinformatics. However, before we dive into our topic of the ecosystem, I first would like to spend a few words on what do we want to achieve with that ecosystem and who do we want to support with such an ecosystem. So typically, when we talk about health-related data, this is a very diverse and a very large field. So quickly, what do we include into these kind of definitions? So when we look here at the data types, we have everything spanning from hospital clinical data, like electronic health record data, or images which are taken when you go to the hospital, like a CT or an MRI. But also we have a lot of molecular and omics data, for example, genomics, transcriptomics, or proteomics. We have a lot of clinical research data, for example, data which is collected in the scope of a cohort or in a clinical trial. And last but not least, we also have the wearables and apps. So for example, your Apple Watch, which collects your heart rate, or the app on your smartphone, which counts your steps. And as diverse as these data types are, you can also see that the origin of this data is quite diverse. So we have data coming from clinical routine or from clinical trials. Some of them come from research. Some of them come actually from billing. And of course, you always need to take that into your considerations when using that kind of data, because maybe there is a certain bias because this data was actually made for billing. Within Switzerland, we have another diversity factor, which is the language. So as you know, we have 4 national languages, of which 3 of them are also represented in the healthcare sector, so German, French, Italian. If you go to a hospital here in Basel, all of your data will be collected in German. But we also have English as somehow the common language, and of course, as the language of research. So we have normally data in these 4 languages available. And last but not least, we come to the data standards. So here actually, you may know there is endless amounts or endless numbers of data standards available. And here I only depicted for one example, the diagnosis, the kind of standards which came to my mind. So for example, we have the ICD-10 for the billing. We have SNOMED-CT, which is a very general standard and can cover a lot of things. We have the NANDA standard, which is used for nursing. We have the ICD-O standard, which is used for oncology. And we have something like the ORFA, which is used for rare diseases. And all of these standards, they are very valuable and very good in the domain they are expressing. And what you can easily say, there's no way that we can actually agree on one standard which covers all of it. And I think this is why it's very important for our ecosystem to not rely on one standard, but actually be able to integrate and link different kinds of standards. And overall, what we would like to achieve in Switzerland is we want to make data fair, so findable, accessible, interoperable, and reusable. So what's the situation today? If someone would like to have data for his or her research project, you have here all the kind of different silos, which we talked about before. So for example, of the clinical data warehouses, we have, for example, a cohort database. Maybe we have some omics data here. And here we maybe have some data from a clinical trial. So as a researcher, you get all that data and you need to, in a very tedious amount of work, need to link all the data, need to understand the data, need to decide what is comparable, what is different. And you can already see that more or less all of our guys here, they do a similar kind of work in understanding and linking the data. And that's why in SPHN, we actually decided to build a so-called semantic description of the data. and actually introduce a kind of semantic layer between the data sources and the researcher. So in such a semantic layer, what we do is we actually describe the data which is there by the use of semantic standards. In our case, it's mostly LOINC and SNOMED-CT, but as I mentioned already before, it can be extended to each and every other standard as well. And then, of course, we need to link the data to say what is the same or how the things are related. And this is actually done with a so-called grammar. And this is actually what we represent here in the graph. And for the representation of that graph, we use the RDF framework, the resource description framework. And what you can now easily see, our three guys before, they can actually hook up to this semantic layer and are actually, it's much more easier to understand the data because it's semantically annotated. And it's not only our researchers who can actually understand the data, but also the machines, because you can already imagine by using the controlled vocabulary, by having the data linked, it is also machine readable. So I would like to quickly dive into this semantic layer. What does it mean? How do you need to envision that? And I took a very simple example, which is the example of fever. And I just depicted a few terms here. Fever, the German word, then we have here the Latin word. We have something like the body temperature is 39 degrees, which every child knows. Yeah, this patient has fever. We have things like the aseptic fever, or we have even here like a text snippet, der Patient hat eine erhöhte Temperatur. And what we can now do is actually we can semantically annotate these data with the term. So what I say here is actually fever in German is the same as, for example, this SNOMED code, fever. Also the Latin word is the same. Also here the French word. And also my text snippet somehow relates to that. And last but not least, also this kind of question, since we answered it with a yes, relates to fever. Here in this snippet, I actually have the body temperature, which is 39 degrees. So actually body temperatures, temperature maps to body temperature in SNOMED-CT. And my aseptic fever, there's a term in SNOMED-CT, which is called aseptic fever. So I map that to that one. And now you see we are already forming somehow like these kind of clusters. And now in order to be able to connect that clusters, we can actually use relations which have a meaning. So for example, for my aseptic fever, I know that this is a subclass of fever. Or for my body temperature 39 degrees, I know that this has an interpretation which is above the reference value. And therefore, this interpretation of this body temperature is fever. So you can already see how this kind of structure here becomes like a graph, because we are really connecting all the pieces and their meanings. So if we now think about a data ecosystem, I think I convinced you by now that we actually need a graph, a so-called RDF schema or an ontology. So in SPHN, what we do, we have somehow two kind of documents. We have the SPHN dataset, which is a kind of table which describes for which data element we use which kind of standards. Because I told you before, we are not relying on one standard, but we use SNOMED-CT, we use LOINC, we use ICD-10, we use ATC. So that is all defined in the SPHN dataset. And then this is translated into the RDF schema, which you can imagine as like a blueprint for later the graph with the data. So as you can see, the space here is still quite empty. So there is a lot of more components to come. And the first thing what we need is a so-called terminology service. So a terminology service actually holds all the external terminologies, so the standards you use, in a compatible way. So in our case, they are represented in RDF, and we can actually make a mapping between these resources and our RDF schema. So for example, between the SNOMED-CT and where we use SNOMED-CT in our RDF schema. Next comes the question, okay, so we have now one SPHN RDF schema. Is that sufficient to cover all the potential research projects which we have in SPHN? And you can easily imagine, no, it doesn't, because researchers are interested in different things, in different granularities. And that's actually why we developed the so-called template RDF schema. So that imports the RDF, the SPHN RDF schema and the external terminology. And then actually there is certain rules and guidelines how projects can extend the schema. And with that, we are ensuring that the project RDF schema is compliant with the SPHN RDF schema because they can use the kind of concepts which are present here. However, they can also extend their concepts. And of course, they can also use the kind of terminology service to actually make sure that they annotate their concepts with the right controlled vocabulary, and also that when representing the data, they use the correct standards. If we then have such an RDF schema, such a project RDF schema, this can actually be provided to what we call a data provider. That can be a hospital or like a center or whoever has some data. And normally these people have what you call the kind of source data. So there's a big database with all the data in. And now what we want for our project is actually that only the patients which we are interested in are somehow taken out from that big database. And then actually they are actually extracted. It's the E here for the ETL process. Then they are transformed, meaning that actually all the kind of standards which we told to be used are actually mapped from the local codes to these international standards, and then actually also transformed into RDF, which is compliant with this kind of schema. And then actually we end up with the project data. What you can see already now is, okay, we now have project data. What is very important when we deal, especially with big data, is that we have a validation of that data. In the RDF world, this is done with so-called shackle rules. So we have here shackle rules, which can be used to validate the data. And these shackle rules, this can be, for example, things like that only a concept which is defined in the schema is also here used in the data. So you cannot suddenly represent some data which you didn't have defined in your blueprint. Also, for example, if you say this data element has to be represented in SNOMED-CT, of course, these shackle rules, because they are also importing the external terminology files, they can actually validate if this is a valid SNOMED-CT term. Now I skipped over this part here. So actually you can already see if you have these kind of shackle rules, you can imagine everyone needs to create this shackle rule. And this is of course very time consuming. And that's actually why we developed here a so-called tool, the so-called shackler. And this tool actually takes the project RDF schema, the SPHN RDF schema, and as I said before, the external terminologies, and generates a first set of shackles. And this set of shackles can be then used to validate the data. However, projects are free to actually introduce more shackle rules. So this is, of course, a possible extension. When the data is then validated, it's actually sent back to the projects. And the project can then actually analyze the data. In the RDF world, this is done over so-called Sparkle queries. So that's like queries with which you can extract data from the graph. And what you can do here very nicely is you can use so-called inference to infer knowledge. So for example, in SNOMED-CT, we have hierarchies or attribute relationships, which allow you then to query for things like, give me all diseases which are caused by a virus. In our data, there is no virus causity annotated. But in SNOMED-CT, for example, we have the causing agent, which can be a virus. And by combining the external terminology and the data, actually this novel kind of queries will become possible. The same as if data is annotated by different granularities. So for example, one person said, I have a broken arm. The other one actually specified, I have this broken bone in the arm. Then of course, you know, due to the SNOMED-CT, how these body sites are connected, and therefore can actually more easily use them for queries. Also here, we developed a tool which is called the so-called Sparkler. So that takes, again, as an input, the project RDF schema and creates you a set of sparkles, actually to extract each concept, which is defined here in the project schema in a flat way. And these kind of queries can be used as a basis to then be extended to more complex Sparkle queries. As you've seen, this is the full ecosystem. It's already quite complex. It has a lot of tools which project can use. And this is why actually one of the core elements of our ecosystem is the documentation and the training, because without that, actually, it's, I think, impossible that people are able to use it and actually are also easily understandable. And therefore, we have a comprehensive documentation, and actually we offer several training modules on these things. Last but not least, I would quickly like to dive into the FAIR aspect. So I told you on the first slide that actually this is an ecosystem for FAIR data. So actually, maybe we can have a short recap on how we are addressing the FAIR criteria with that kind of framework. So as you may know, there is the F1 criteria, which is the unique identifiers. So in the RDF, actually, all resources and all concepts get a unique identifier. So this is covered. The F2 is we need rich metadata. This is actually covered by the SPHN concept. So we really try to put as much metadata to the single data points as possible. So for example, for the heart rate, we are collecting the measurement method or the body side where it was measured. But also we have somehow in the template a kind of general metadata information section. So this is, for example, who is the author of the data set? When was it extracted, by whom, which ontology was followed, and these kind of elements. Then we have the A1 criteria, which is the universal query language. So in the kind of the RDF world or the semantic web world, this is the SparkQL. We have the interoperability criteria E1. This is the language for knowledge representation. This is actually done in our case by the RDF. Then we have the E2, which is the controlled vocabulary. Here we are using LOINC and SNOMED-CT. We have the E3, which is the linked data itself. So this is RDF via the common URIs of the controlled vocabulary. And then actually for the people who are very familiar with the FAIR criteria, you realize that I actually missed them F3 and F4. And also I'm not depicting R1 here. So these are FAIR criteria which to my understanding or to my interpretation are in the responsibility of a project, so that you put your data into a repository, that you assign a license to your data. And here we are, of course, recommending the SPHN projects on how to do this, but it is actually not covered by this framework, what I presented today, but it's covered in the overall SPHN framework. And with that, I would like to quickly thank our partners, because building such an ecosystem is a large collaborative and iterative effort. So I would like to thank the representatives of our 5 university hospitals, my colleagues at SIB, and my colleagues at Trevadis, who helped us a lot to build this kind of framework. Thanks a lot for your attention, and you're welcome to write me questions via email. Thanks a lot and have a nice day.